This is a video for Diffusion 3, Outstanding Osmosis. How does water move in and out of a cell? Follow along as I read. Water is a unique molecule that moves in and out of cells, from areas of high water concentration to areas of lower water concentration. In fact, water is small enough to enter a cell without having to be digested first. The movement of water across a semi-permeable membrane is called osmosis. Osmosis occurs when water concentrations are different on both sides of the cell. There are three types of solute concentration, and they are described below in Table 1. So let's make note of some key points. First of all, we have the definition for osmosis in here, and I would like you to define this in your own words. Also, we should make sense of this article. So we should sketch this in our notes. Typically, a cell will be, around maybe 5% salt, maybe less, between 1 and 5% salt. It's typically mostly water. When you put a cell into distilled water, that is 100% water, note the arrow is going in. That means water is moving into the cell. The cells will burst. In ocean water, it is the same concentration as the cell, and the water moves both directions. There is no change. In a salt solution, where we have less water and more salt, water will move out of a cell and the cells will shrivel. Again, this should be sketched in your notes. We have right here a table, and this table says, Table 1, comparison of solute concentration and water flow. We have different columns. We have solution, description, water flow, examples, and a drawing. And these little dots represent salt molecules. They can be any dissolved substance, like sugar, glucose, but usually it will be salt. Now, in here, we should really be paying attention to these two columns. These terms, while it would be great if you knew that, they are confusing. They are words you probably haven't seen before. You can use the root word list to figure them out, but you will not have to know these for the regions. This part should be copied into your notes. Okay, let's continue. During the diffusion through a membrane lab, you learned that water and salt solutions can have opposite effects on living cells, like the red onion. Hypertonic solutions, like salt water and sugar water, force water to flow out of the cell, causing the cell to shrivel. Plant cells contain a rigid cell wall for added support, so the cell membrane separates from the wall in a hypertonic solution. If a plant cell were to be placed in a hypotonic solution, like distilled water, the water will flow back inside, causing the cell to plump up again. However, since the wall is rigid, there will be no permanent damage to the cell. So we have right here this sentence about hypertonic solutions. Can you explain this, please, in your own words? Do this in the margins. Now, note right here, when we add salt water, what happens in salt water? Make sure you can explain this. And finally, when you add distilled water, it's going the other direction. In your notes, I would actually sketch this twice because this diagram might not make sense to all learners. Let's take note of the different parts, which you should also be putting in your notes. We have a cell wall. Note the cell wall is the outside. We have the cytoplasm. Note where the lines are pointing. We also have the cell membrane. Note what happens to the cell membrane. You should be able to sketch and label both of these parts. You will have to know this.